Yesterday we spent some time talking about the two types of errors that can occur when doing a hypothesis test, and those are summarized here. I'll give you a moment to write those down if you didn't get a chance to finish that yesterday. So today we're going to build on those ideas from the previous slide. An alternative way to summarize the previous slide would be the four boxes we see here. If the null is true and we reject it, that would be an error. We call that a type 1 error. If the alternative is true and we fail to reject the null, then that means we've made a type 2 error. And the other two boxes here are good. Now, usually what we're most interested in is whether or not our theory is true. So one of the things that we're going to investigate today is our theory lies in the alternative hypothesis. So the question is, how likely is it that we reject the null when the alternative is true? So we're looking at this box here today. So to do that, we're going to go back to where we started. We started this unit talking about Ms. Wadley claiming that she was an 80% free throw shooter. And what we're going to, and I suspect that perhaps she's less than an 80% free throw shooter. So this is my suspicion. Remind you that when we did this, we said that either she is truthful or perhaps she's exaggerating and she's really less than an 80% free throw shooter. And we had her shoot 50 free throws just to test the conjecture that the percentage of all free throws that she made was 80%. So when we look at a type 2 error in this setting, I'll have you pause the video here and talk with a partner about what you think a type 2 error might be in the context of this problem. And here's our boxes if you find those helpful in doing that. So go ahead and talk to your partner. We'll pause the video. So in the context of this problem, a type 2 error would be that the alternative is true. To put that in context, Ms. Wadley is exaggerating, but we fail to find convincing evidence of that. So that would be the type 2 error described in the context of this problem. Ms. Wadley is less than 80%, but we don't find the evidence of that. So let's suppose that we actually knew the proportion. This is not unlikely, but for the sake of investigating what goes on in this box up here, we're going to suppose that she actually is a 66% free throw shooter. That would mean that this alternative that we have up here is true. She's less than an 80% free throw shooter. So what I'd like you to do right now is I'd like you to enter that information, go to the website that's listed here, and click to display the type 2 error. You will see that shaded region in blue. That would be the probability of a type 2 error. So confirm that that is 24% when you do that, and then answer questions B and C in this problem, please. Again, we'll pause the video and allow you to do that. So we can drag here. The hypothesized value for P is 80%. So notice that this red curve shifted to where you see here. We are now assuming that she's an 80% free throw shooter. Our alternative hypothesis is she's actually less than that. We want to display the type 2 error. The true value of P is 66%. And we're doing a sample of size 50. So there's our sample of size 50. Now notice at the top of the screen here, they're saying the probability of a type 2 error is 24%. So if we think about it, we're going to reject, using this red curve to make our decision, we're going to reject the null hypothesis when we have 5% of the curve in this region or less. So this area under the red curve between the x-axis, that little white area in there, is going to be 5% of the total area underneath the red curve. So that would be when we'd be rejecting the null. We'd be failing to reject the null when it is bigger than that. So the probability of a type 2 error would be determined by the area under the blue curve, because the blue curve presents the reality of what's going on. The red curve represents what we think is going on if the null is true. So the correct decision here, because it really is less than, the correct proportion is less than 80%. She's actually a 66% free throw shooter. So what we would find is that we would make a type 2 error. We would be failing to reject the null when we're to the right of this value that separates the bottom 5% under the red curve from the top 95%. We'd be failing to reject it when we're bigger than that value, and the probability of a type 2 error then would be the area of that red region, or that blue region under the blue curve, and that's 24%. So if the alternative is true, and Ms. Wadley is actually less than an 80% free throw shooter, she's really a 66% free throw shooter. If there's 24% probability of making an error in that situation, there's a 76% probability that she would make the correct decision. So basically what we're saying is these two numbers here are the only things that can happen if the alternative is true. So those have to add up to 100%. The probabilities of these two things must add up to 100%. The website just told us that this probability under these conditions would be 24%. So this probability must be 76%. And that's where this number comes from. So to interpret that value in the context, we would say if Miss Wadley is in fact a 66% free throw shooter, there's a 76% probability that we will correctly decide that she was exaggerating. There's a 76% probability that she will correctly reject the null. This idea right here is called the power of the test. So what we're going to do today is we're going to look at some things that affect the power. So I'd like you to use the website to alter the things, the sample size, the alpha level, and the alternative p, and see what happens as you adjust those to the power. So as n goes up, let's see what happens to the power here. So we're increasing our sample size from 50 to 75. Notice that the power increased here. The power increased from 76% to 88%. Notice that the type 2 error and the power still add up to 100%. If we increase the sample size further, say we go to 125, now the power is 97%. So this is saying 97% of the time, when the alternative hypothesis is true, we will reject the null hypothesis. We'll correctly identify that our theory, which is housed in the alternative hypothesis, is true. Okay, so the effects of increasing the sample size increases the power. Likewise, decreasing the sample size decreases the power here. So we'll return the sample size back to where it originally was, having Ms. Wadley shoot 50 free throws. Now let's investigate what happens as we alter alpha. Alpha, or the probability of a type 1 error. So if we make it more likely to make a type 1 error, more likely to reject the null hypothesis, say our alpha level is 0.08, then that's going to make it less likely that we fail to reject. So the probability of a type 2 error is going to go down. And as that goes down, since these two things up here, the probability of a type 2 error and the power add up to 1, then the power is going to go in the opposite direction. It's going to go up. So as we increase alpha, we increase power. As we decrease alpha, if alpha were to go to 0.02, we're going to decrease power. So again, it comes back to being really clear on the consequences of making each kind of error. Because if we have very grave consequences for one type of error versus the other, then we want to take that into account as we set alpha. The last thing we wanted you to investigate was the difference between the true value of p and the hypothesized value for P. So let's keep the hypothesized value at 80%. Now, if we move the real value of P closer to 80%, notice that the power goes down. And I think that makes sense. It's harder to detect a difference that is small. Like if Miss Wadley was actually a 76% free throw shooter, it's really unlikely we're going to be able to distinguish a 76% free throw shooter from an 80% free throw shooter. However, if we have a very big difference, if Miss Wadley would actually make like 8% of her free throws, we're really confident that we're going to be able to pick up on a discrepancy that large. So to summarize, I think there are three things here: sample size, alpha level, and the alternative value for P. And as n goes up, the power goes up. As alpha goes up, the power goes up, because as alpha goes up, the probability of a type 2 error goes down. And the type 2 error and the power work in opposite directions since they add to 1. And again, the bigger the difference between the hypothesized value for P, we sometimes will label that P sub 0, and the actual value of P. As that distance between those two goes up, the power will go up. We'll be more likely to correctly reject the null hypothesis. So in our box to summarize our learning for today, our learning target was to interpret the power of a hypothesis test and identify the factors that affect the power. So we learned today that the power is the probability of rejecting the null hypothesis when the alternative is true. We're interested in this because our alternative is where our theory is, and we want to know the probability that we correctly validate our theory. Three factors that affect power: n, alpha, and the distance between P and the hypothesized value of P. And basically, all three of these things move in the same direction. If you increase n, more data is better, so you're more likely to make a good decision. If you decrease n, you're less likely to make a good decision. As alpha increases, we make it more likely that we reject, we make it less likely we fail to reject, which is the probability of a type 2 error. And so power, which moves in the opposite direction since they add to 100, will go in the same direction as alpha. And if there's a big difference between what you think is going on and what's actually going on, you're more likely to pick up on that than if there is a small difference between those two things. So I'll have you now work on the Check Your Understanding on the blue page, page 19 in your packet. Here are the correct responses to the Check Your Understanding. I'll have you pause the video here and make sure that you agree with the answers that you see. And here are the correct answers to the Check Your Understanding on the previous section that we talked about yesterday that I asked you to do for today. These are on page 17 in your note packet. Okay, there will be an assignment posted for you guys to work on.